Thank you and good evening, everyone. Welcome to the Computer History Museum. I'm John Holler, the President and CEO, and it's my pleasure to welcome all of you tonight to this Revolutionaries event on behalf of our trustees and our staff and our members and our amazing volunteers. It's just so great to have you here tonight, so thanks for being here. You got a little taste of what we're going to be talking about in great detail tonight. I think that was very exciting. First, I just always like to mention at the beginning that these evenings are made possible by Intel, who is the lead sponsor of our Revolutionaries series, now for the 4th year in a row, and this year we also have funding from the William K. Bowes Jr. Foundation, so we're very grateful to them. When we began putting together our short list of historic research labs to profile in this year's museum series on Revolutionaries, it only took us about a nanosecond to include SRI International. The intriguing thing to me, and perhaps one of the wonderful things about great research and development labs, is that when they work really well, they're nearly invisible to us, almost like the technology they invent. And even when their output has high social impact, SRI is definitely in that category. Just a short list of SRI's contributions to computing: breakthroughs in artificial intelligence that extend back to the late 1960s and the famous reasoning robot, Shaky. That little thing we call the mouse, which completely changed our concept of how we interact with the truly personal computer, conceived by Doug Engelbart and engineered by his good friend Bill English. Major developments in packet radio, which paved the way for mobile computing and mobile telecommunications. The first successful computer-to-computer connection on the ARPANET, which led to the globally networked society that we all enjoy today. And finally, if you add the letter I into the middle of the acronym SRI, you get the word Siri, and that's no accident either, because Siri is one of SRI's breakthroughs. Today, Siri is working in information security, intelligent systems, natural language, vision and perception, reasoning, interactivity. That's just in the computing and information section. With us tonight to discuss SRI's storied past and its new future, our President and CEO, Dr. Curt Carlson, and Information and Computing Sciences Vice President, Dr. Bill Mark. Bill will come up first, and then Curt will join us in a bit. Guiding the interview, as he has done for the entire lab series, is a good friend of the museum, John Markoff of the New York Times, and I need to note that on Monday, John won the Pulitzer Prize. He won with a team of New York Times reporters in the category of explanatory reporting. So tonight, to help us get very smart people to explain it all to us, please welcome John Markoff and Dr. Bill Mark.
You know, the series is part, particularly for me, about understanding the ecosystem of Silicon Valley. And there are lots of myths that are true and some not so true about Silicon Valley, but one of the myths is that innovation comes from college dropouts in garages. and I think if you think about it for just a little bit, I mean, where would homebrew have been without Park and Sale and SRI? And where would Facebook and Google have been without DARPA, or then ARPA, and SRI? And you know, I think you can see that there's a common theme emerging here. You know, the reality is that fundamental innovation often comes from corporate research labs, and you know, GASP it even is funded by the government occasionally, in fact, frequently. And so we've been trying to sort of explore that subterranean ecosystem, and we're going to focus on SRI tonight. And we're going to start more focused on sort of the computing part of SRI, and then we'll invite Curt Carlson up and we'll expand it to talk about the sort of the full breadth of SRI, which is really quite stunning. And we're also going to, I think, mostly look forward today, but with Bill Mark, I sort of wanted to get a little sense of this trajectory of your career, and so look backwards initially. And you know, you started at MIT. And I'd sort of like to know sort of which generation as a computer scientist. There are many generations of computing at SRI. One of them was profiled by Stephen Levy in Hackers. Where were you in that sort of evolution?
Well, I started at MIT when computer science was actually still a pretty new discipline. Just to place it in terms of AI, Terry Winograd was finishing up his thesis. He was the senior graduate student God, and Patrick Winston was finishing up his thesis. I learned how to program a PDP-10, a decent, half-decent PDP-10 assembler language programmer, in case anybody needs that.
And so, were you around when the hackers were at the AI lab, and were you focused on AI a lot?
I was definitely intrigued by AI. I was actually in Project Mac, as it was then called. Spent a lot of time in the AI lab, and yes, I knew some of the hackers.
Yeah. And so, which part of, in terms of your thesis or the things you focused on in Project Mac, what were you working on?
I eventually ended up doing work in knowledge representation. And I got interested in how people with expert knowledge were able to map problems that they saw into their expertise. So I had this idea of reformulation, and that's what my thesis was about.
And then did you go on into AI as a career, and did you go through the AI winter? I know you're actually, you have this very diverse background, and was AI the first?
Yes, it was a little more complicated than that. So I went to work for General Motors Research Laboratories, and I was actually doing natural language interaction with databases, which they were very interested in at the time. And then I went on to ISI in Southern California, which is part of USC, is a nonprofit research laboratory, and worked there also in AI and knowledge representation.
I see. And
then I went off to start a company.
An AI company?
Sort of. Certainly something that was trying to bring knowledge-based systems, so I guess you'd call it AI, to the world of manufacturing, of all things.
Okay. And was that a case of being too early?
I like to think so. It certainly was a failure. So I'm absolutely sure it was a brilliant idea that was too early.
Yeah. Okay. So did you come from a generation at MIT that was sort of, you were significantly prior to personal computing? What did you think about personal computing when it sort of showed up on the scene in the mid-'70s?
So when I first came to MIT, it was all about time sharing, and that's what I thought computing was. And I certainly saw personal computing coming. Everybody did. Starting off with some very clunky machines, some of which are here in this building. So it was actually pretty hard to take seriously at the beginning. I didn't take it all that seriously. They weren't very good machines for AI at that time. But that swiftly changed.
Yeah. And so going a little farther back than that, you grew up in the center of the country. How did you get to MIT?
Well, I grew up in the Midwest. I'm actually from Minnesota. And I got very interested in science at a very early age. I can't remember not being interested in science. I used to read all kinds of science books. But I certainly didn't always want to be a computer scientist. In high school, I went through a brief period of wanting to be a journalist, of all things.
You got over that quickly, I see.
I did. I actually was assigned to interview rock stars who came to Cincinnati. And believe it or not, that included Jimi Hendrix and the Jefferson Airplane. So I talked to those people.
So who was your favorite interview?
Oh, Jimi Hendrix.
Okay.
Wonderful, very quiet. And my opportunity to talk to him was right before the show. And he was surrounded by people trying to give him guitars to play, as well as lots of girls who wanted to say hi. But he was the consummate professional. He was just totally focused on those guitars, how well they were working, and so forth. So anyway, that was very cool. But I discovered that I was a horrible journalist.
And did that place you after Sputnik? Had the Sputnik stuff happened? I'm just wondering if that had sort of shaped your interest in science at all.
No, I don't think that shaped my interest in science. I do remember getting very engaged in Isaac Asimov's robot stories and the 3 laws of robotics. And I'm not a big science fiction fan, but I remember that very vividly because I thought it was so cool to think about the implications of those 3 laws. And I'm sure a lot of you have read these stories. A number of them are about people trying to understand why the robots were behaving the way they were. And they had to figure this out, and it was debugging, as we would consider it now. But it really got me thinking about the nature of intelligence, which is really what AI is all about. So that got me interested in AI.
And just so you weren't a big science fiction fan, but did you stumble across the Foundation trilogy?
Yes.
It's funny because almost every big data person I've run into is sort of like deeply influenced by the Foundation trilogy. Right? That had the same effect. So let's skip forward.
Thank you.
So in running a CS department, basically, at SRI, how would you set it apart from what goes on at Stanford or Microsoft or Park, for example? What's different about your work?
Well, some things are similar. Let me just start there for a second. So I think one of the things that's incredibly important about SRI is that there's this culture and mindset of doing big things, changing the world. And you saw some of those in the earlier presentation. And people come to SRI, certainly in the computer science area, to add another slide to that list. And that really motivates people.
And culturally, are you able to do that in this sort of, we have this classic Silicon Valley hothouse period. There have just been stories recently about whole groups of people leaving Stanford at once. Do you have a sort of management problem of people being cherry-picked by?
Oh, we have competitors. Some of them are sitting here. But we don't have wholesale groups leaving, and that's in part because, getting to your question, we have what I think is a unique mix, because we really do research, we do real research, and because a lot of it is government funded, that means that we work closely with university researchers. So there's this community of what I think of as some of the hottest researchers in the country in computer science. Plus, we do stuff in the commercial world. In particular, we start companies, which is very exciting to people. And that's a big attractor for us.
And is that something that's actually spun up under Curt? I mean, is that a culture that's evolved over the last decade, 2 decades?
Well, definitely, yes. I would say that when I came to SRI, one of the things that brought me to SRI was the very beginnings of that, this strategy of having the research be also used to create things in the commercial world. Curt came about 1 year after I came, and then it really took off. And in particular, the idea of spin-off companies took off.
Yeah. Before we leave your past entirely, you also spent time in the semiconductor industry.
I did.
And I didn't get a chance to ask you about this, but were you there as an architect, or were you there? So this was at National? Or?
Yeah, right. I was at National Semiconductor, and I ran something called the Architecture Lab. So I wasn't the architect, but there were certainly architects working there. And the whole idea there was, this was the emergence of systems on chip, and the systems were getting very complex, and the hardware and software had to be delivered in the same kind of bundle. And that's what that lab was all about.
And was that during the RISC era or after the RISC era? System on chip was a little after?
It was after the RISC era.
Yeah, okay.
During the RISC era.
Yeah. So do we have to debunk a myth here about Siri? Do you know the story of how Siri came to be named?
Yes, I do. So at SRI, when we do spin-offs, so first of all, like as you were saying before, like a lot of these things, Siri is decades in the making, right? But when we see a disruptive opportunity, we bring in an entrepreneur from the outside. In the case of Siri, the entrepreneur, Dag Kitlas, is of Norwegian heritage. And he chose the name Siri, which is, I gather, not an uncommon, but not a common Norwegian woman's name. Okay, that's Siri. Okay, and also because he could get the domain name.
Okay, so SRI was just a four-letter domain name. It's still a pretty good deal.
Yeah.
Yeah, that's impressive. So I've been around long enough that I can actually remember being given a voice recognition demonstration by Gary Hendricks at SRI probably 81 or 82.
Yeah, that'd be right.
I think it was called the Admiral's Advice. Well, I can't remember what it was called, but basically he was able to say left and right.
Yeah.
And controlling the battleship. And
did it work okay?
The demo worked, yeah, but it was sparse.
Yeah.
And so that's why, I mean, for me, Siri is such a tour de force, because you can clearly see, you've made such extraordinary progress over.
It's been amazing. And so there's progress in certainly the speech area, where right now, automatic speech recognition, certainly if you're on a smartphone, works very well for a lot of people, which is big news. But in addition to that, the AI, the reasoning part of Siri made tremendous progress.
Yeah. So one of the things you said in a note to me is, I see Siri as a step toward the future of one-person interaction. And that was a phrase I hadn't heard, but I'm intrigued. So give me a sense of what one-person interaction.
Well, almost everything that people think about in terms of human-computer interaction is about one person talking to a computer, a computational device. Okay? And that's extremely important. That's what Siri is. And we're working right now on generations after Siri and so forth. But still thinking in terms of one person talking to a device. But as we go more into the era of ubiquitous computing, then you have to think about space. And when you're in a space, a computational space, if there's another person in that space, in most circumstances, there's going to be interaction between the people. The people will talk to each other. When people occupy the same space, they tend to talk to each other. And they will talk to the devices in the area.
So that seems to touch a little bit on the idea that I knew of as ubiquitous computing, but it's not the same thing? Would you differentiate it?
Well, I think it's looking at the future of ubiquitous computing. Because when I think of ubiquitous computing, I think of Mark Weiser and Xerox PARC and the idea of smart environments. And I think that's absolutely true. It's coming. Your car is one. But there hasn't been enough focus, in my opinion, on what happens when people occupy those spaces, because they're going to talk to each other. And it's also fascinating because we've worked very hard to make computation independent of space. So computation actually doesn't care where you are almost all the time. But people think completely differently. We act very differently in different spaces, right? You act differently in your living room than you do in your office. And I think a world is coming in which the computation in that space has a sense of the space and what people will be doing and how to help them.
And within that framework, you've also broached this notion of a virtual personal assistant.
Right.
Is that like an application within an intelligent space? Is that what you...
Well, virtual personal assistant transcends both one person talking to a computational device and many people talking to a computational device. And we're actually working on both of those.
Yeah. You just spun out another company that hasn't gotten quite as much attention as Siri. There's a company called Tempo that does intelligent calendaring, which you can get on your iPhone now. Does Tempo use a different set of AI technologies? I mean, what differentiates it from the stuff we see in Siri or underneath Siri?
Well, Tempo, which, by the way, got a huge amount of attention, they completely underestimated the demand that they would have and were swamped but they're through it now, so please use Tempo. So Siri, the idea of Siri is to have a conversational interface. And the original Siri spin-off, the idea of that was to have people be able to get things done through conversation. And when you think about it, that's how we do a lot of things. We get things done through conversation by talking to other people. In this case, we're talking to a device. Then the VPA concept, virtual personal assistant concept that you mentioned before, has actually taken that further to start having even more in-depth conversations about doing complex tasks like banking or education, that kind of thing. Tempo is using a different paradigm. So instead of the focus being a conversation, the focus is the calendar. And the great insight was that when people put meetings on calendars, they are expressing an intent. When you say something in a conversation, you're expressing an intent. when you put something on a calendar, you're also expressing an intent, and we can do reasoning, AI, et cetera, based on that intent.
And is that, I mean, so if you look at the sort of the big threads in AI research these days, I mean, you know, there is this Bayesian world now that seems to have taken over everything, but you came out of an expert system world.
Yeah.
The tempo technology, does it pull on some of those expert system threads?
It does both. So the cool stuff, I think, is happening at the merger of those two things. So there's some statistical modeling that goes on. There's also some reasoning, logic type reasoning that goes on. So it will, if you set a meeting, it will automatically, if you let it, find things in your email, pull out the emails that are relevant to that meeting, find documents that are relevant to the meeting. It'll look up the attendees in LinkedIn, that kind of thing. It'll look up the location for you and give you a map. Okay. And they have lots more ideas.
And do you think these interfaces are sort of the stuff that's in Tempo and in Siri and that came out of this Kalo project that was funded by DARPA, do you think it's powerful enough to basically you know, I keep wondering when the computer is going to disappear entirely and whether these things are actually first steps toward, I don't know if it's Star Trek computing or whatever it is, but the disappearance of the computing in terms of interface. How quickly?
Well, I do think that it will, and I think that that is relevant to that mediated spaces kind of thing I was talking to you about before, where right now, I mean, the generation that's growing up, when they're talking to Siri, they don't think of that as a computer, I don't think. Yeah. They're not aware of the computation going on, and now more and more people in their car have conversational interfaces. That doesn't seem like a computer to them.
So in the graphics world, there's this long-time term called the uncanny valley, about this world where you get to this sort of surreal period before you cross over and it's natural.
Right.
Could you see an uncanny valley being crossed over and interacting with virtual personal assistants?
Yes, and I think that in fact people are too ready to cross over that valley because we bring so much to a conversation. We're so willing to read in to what's going on the other side that we're going to expect, but we already see this, by the way. We think of the thing as being more human and more capable than it actually is.
Which goes back to Weizenbaum, basically, in some sense.
Well, so Weizenbaum, so ELIZA, I think, was 1962 it started, so a really long time ago. And very, by modern standards, primitive technology, but people were bringing so much to that conversation that they thought these little things they were getting back were intelligent behavior.
So social and economic consequences, how profound?
Oh, profound. I think the thing that gives me hope is people are very smart and adaptive, and I think they're going to get used to this world of conversational interfaces, and they will know where to put it in their conceptual framework. I think we're seeing that with Siri right now.
Yeah. And then sort of the freakonomics aspect of this, I'm probably derelict for not having reported this, but I have seen, let's say there was this vast outsourcing of call centers to India and to the Philippines, and I believe that those jobs have already come home in significant numbers to run as software in data centers. That you could measure that, although the companies are not cooperative in terms of the numbers. But so where does that end?
I certainly don't know where it ends. I've also heard about that trend. I think it will continue. And I think this is a very natural thing where technology causes disruptions and then people adapt to them.
Yeah. So talk just a little bit about the roots of Kalo. Tony Tether has been criticized so much by particularly the academic community, but wasn't he, to what extent was he key in Kalo, and was it a favorite project of his?
Well, Tony was absolutely critical.
Tony Tether was one of the heads of DARPA for many years, actually.
Yes.
And during that period, there was a lot of conflict with the academic community. But he pushed Kalo?
Oh, yes. So Kalo was an idea that was created by Ron Brockman and Zach Lemnios, who were part of the Information Technology Office, as it was then. And Tony absolutely embraced this project. He pushed it to be more and more researchy, really wanted to push the edge. absolutely wanted to focus on learning. You mentioned the academic community. SRI ran that program. I was one of the principal investigators. If Ray Perro is somewhere out here, he was the other one. We had 20 plus university subcontractors working on this project. So Tony was critical to it.
Yeah. So I see where I want to bring Curt up soon, but let me take one more sort of step into the AI world. You know, I noticed when I was reporting on my last book that there were sort of two labs in the mid-'60s on either side of Stanford University. There was SRI, Doug Engelbart, there was SAIL, John McCarthy, and if you sort of think about what they were doing, SAIL, at that point, John McCarthy project was to replace the human being, the human brain, and the human itself. And they thought it would take about a decade. No, it was in the first proposals, yeah. 1975. Which brings us to Paul Sappho's never mistake a clear view for a short distance. And on the other side, Doug Engelbart was trying to augment human intelligence. And I know that it's a spectrum, but there's also been this tension, hasn't there, all the way through. And sort of as a designer, how do you think about where to put the human in and where to take the human out, now that you can do it in so many places?
Well, so for me, as soon as you adopt the notion that one of the tools, in the Engelbartian sense, one of the tools that could augment the human intellect is something that's also intelligent, okay? Then those two things come together immediately. Yeah. So that's, in the normal human world, forget about computation for a moment, that's how we work. We work in teams, we work with other people, we work with assistants, okay? They augment us. So to me, that's the convergence of those ideas.
Okay. And if you had to bet on the consequence of this sort of wave of technology that's coming out, will it be with minimal or more disruption?
Well, again,
economic or otherwise?
I think it will. I personally think that it will be a smooth transition because, as I told you, I think people are very adaptive to this kind of stuff. So the technology will come on, will get better and better, and people will adapt to it.
Okay. Curt Carlson, this is a good transition point. Why don't you come on up? So Curt has run. You're an evangelist, but you're also the CEO of SRI, as I know, since 1998. Yeah. And you're a physicist by training, and you were deeply involved in the development of the HDTV standard. Mm-hmm. And your expertise is in sort of the physics of perception, in a sense.
I ran a perception group, I ran a computer vision group, I ran the high definition television book program when I was at RCA, and that was bought by GE, and I still ran those programs. I was actually running a program called Heights before there was an internet. It was called Home Entertainment Information Transactional Services, Heights.
Where did Heights go?
Heights went nowhere. We were way too early. It was before anybody even thought about having an internet. And I had Citicorp and NYNEX as my partners and a big team, but it was way, way too early. So I had some interesting experiences at RCA.
I sort of telegraphed what my first question for you was going to be, because I started doing homework on sort of what is SRI, and I focused pretty narrowly, it turns out, on what SRI is. And when I started looking, and you just go to their website, and here's this organization that does software, they do educational research, they do CS research, you're into building satellites, they run radio telescopes, you do biotech, and you're a nonprofit. So my first question is, what's SRI? What are you?
Well, Bill was saying it. It's a collection of people, first and foremost, who really want to make a big, positive contribution to society. It's an organization that's part of the culture, obviously, of Silicon Valley, but it really is a group of people who literally want to change the world for the better. And we talk all the time at SRI about what we call important problems, as opposed to ones that are just interesting. Important, not just interesting. And it turns out that's also a good business model, because many of the folks in this room, I'm sure, feel this, that what motivates people is having the chance to work on a big, important problem. Right? That attracts the best people. You can also raise money if it's a big, important problem. You also have the time to do that. And you can also have the best partners. Everything we do, which one of the things that's a little bit different about us, is I think everything we do is with great partners. So when Bill said we put the Kale team with 20 universities, it was the A team. You know, it was the best people from CMU and Stanford and MIT. And we're able to form these teams to go after these big, hard problems. And with a very high probability, be successful with them.
And sort of in terms of scale, is your revenue around 600 million? Where is that a ballpark?
Yeah.
So give me a sense of, I mean, so let me think about you compared to MITRE and RAND, for example. How would you be very different than they are? Or are there similarities that?
Well, so, you know, we all kind of do research. I think that, again, what makes us different is maybe a couple things. One of which is we really do go after these big, hard, important problems. And that's part of the culture of the place. We do team with the best people in the world. That's part of the culture of the place. That's just the way we think about it. We have a formal innovation process that we teach everybody at SRI. Everybody who comes through the door, we teach them. Bill was very modest about forming Siri, but that was years of work where Bill and his colleague Noel Winarski played the key role, and we actually have a process in place to incubate major companies like that. Very few companies take innovation as seriously as we do. We have a formalized process, that, as I said, that we teach everybody. And the incubation processes we have, some of our venture partners are in the room. Tonight, we work with the best venture capitalists in Silicon Valley, and you put all those pieces together and you begin to get a pretty unique place.
And the relationship to the venture community, it's relatively new. Is that true?
Well, it's been deepened over, as Bill said, over the last 14 years, and we've cultivated a group of venture capitalists. I think we've done 4 companies with Gary Morgenthaler. We've done 4 or 5 with USVP. We've done 4 with Mayfield. You know, it's we've made friends, and we keep on going back to our friends. We like them, they like us. We keep on doing things. So.
And are you about 80% government?
Yeah, about 80% government. So government pays for the research, basically the fundamental research, and then we commercialize it either by forming a partnership with a company, or we do a license, or in the case of many of Bill's companies, he actually incubates them in our formal process where we're constantly putting together about a dozen companies at one time, and maybe 2 or 3 of them will spin out every year.
But given that 80% from the, what's the sequester mean to you? How serious is the sequester in terms of?
So far, it hasn't been terrible. It's obviously not good for anybody in the room. That kind of confusion in Washington is not a very helpful thing. Our commercialization work seems to be going along fine, and many of our groups have had very little impact from it. Some others a little bit more, but we'll be fine. The world's a big place, and you know, even though we're 600 million on the scale of research and innovation worldwide, we're still pretty small.
And so the relationship with the venture community is one part of your connection to the Valley ecosystem. Do you have a sort of a larger, I mean, where does SRI fit into Silicon Valley, just writ large?
Well, that's a good question. We're here tonight. We show up all over the place. We show up at the Churchill Club. We obviously have many friends here. We work with different companies in the Valley and different things. As you said, we're often, or maybe John said it, that people often don't know what we do because we're kind of the partner behind a commercial entity. So, you know, we licensed the computer mouse to Steve Jobs at Apple, right? So how many people know that 2 of the biggest innovations that created Apple came from SRI, the mouse and then Siri, right?
Yeah. And so I also got the sense from some of the earlier interviews of yours that I've seen that you dislike the term think tank. And
Ooh, no.
No, not true?
We think really hard, but we are a do tank. until you get the research, and we do lots of really fundamental research. Don't get me wrong. We think hard, but our folks really are motivated to get the work that we do out to help people. So if it's a new drug, 2 years ago we came out with a new drug for T-cell lymphoma, terrible cancer. There hadn't been a previous therapeutic for that. So that, to us, that's a huge win when we can do something like that. Not only do the research, and so now we're working on Alzheimer's, we're working on various cancers of different types. There's a whole portfolio of things, and the goal is, yes, to do great research, but it's how do you really help the world? How do you make an impact on the world? It's the sense of achievement and impact that really motivate people, and it's what the Valley's all about. It's why people are here tonight. It's how do we get better at this? How do we do a better job? How do we make a bigger impact?
And at times like this in the Valley, when it's so overheated and there's such a sort of an urge to start up, does that make things difficult for you as a manager? And sort of, do you face cherry picking? I know you've set up a mechanism for your people to go out, yes. But how much does that protect you from?
Well, I would say if we didn't have our policy of commercialization, then they'd always, because people do want to see their work get out into the marketplace. So if we didn't help them do that, the natural urge would be like, which often happens with big companies, the only thing they can do is leave, right? Because the company decides they're not interested in that project, for good reason, but they have no choice. In our case, we have a really proactive, thoughtful process. So if we have a great idea like what Bill and Ray and the others did with Kalo, the first reaction we have is, where can we go with this? And we start incubating. And actually, Bill and Norman incubated it for 3 years before we finally spun it out. It was a long time. And our people have learned that unless we do that homework, unless we really stick to the fundamentals, you can't be successful. I don't know what the numbers are. Some of our venture friends here can tell us, but an incredible percentage of venture capitalists don't make money. But some make money pretty much all the time. And the way I think about it is the really good ones and the partners we've had are the ones who really stick to the fundamentals. They understand that when you form a company, you're in the Olympics. It's not the Olympics in your backyard where you can pole vault, over the chair. You're competing in the global innovation economy where everybody knows what you're doing. They hear about it instantaneously, so there's no hiding. So you have to realize the bar isn't here, it's up here. So you really want to work, it's one of the reasons why we always talk about who's the best partner, who should we be working with us, how do we assemble the best teams, because we're all in the Olympics now, the worldwide Olympics. We can't hide anymore, so some of this is driven by that.
You have this very systematic innovation model. Where did it come from? Did you bring it with you when you came to SRI?
I brought some of it was here. I would say I am very passionate about teaching innovation, the fundamentals of innovation. One of the things I helped bring was a very systematic process for that. So we have workshops that we give to our people on the fundamentals of innovation. We've had thousands of senior executives from all over the world, BBC, Swisscom, all kinds of companies you'd recognize. Most companies don't have an innovation process. It's hard to believe, right, given the importance of it. And there's a simple test you can all do when you go back to your companies, which is ask a middle-level professional to describe the company's innovation process. And if they can't describe it, there is none. It's that simple. And you'll discover, you'll find only a handful of companies that really have a thoughtful way to help their people think about doing things that matter, big important problems. Everything starts there, right? And all the other things that come underneath that.
And is that, there's a lot of hand-wringing over the last 2 decades about the decline of basic research in America. And is that, so if you talk about innovation, is there stuff within that framework that you would call basic research that goes on at SRI? A significant
Absolutely.
Amount of stuff? And you
Absolutely.
Encourage it? And
No, the goal is always to do better research. So yes, absolutely. You know, let's pick on the big important problems. Let's have better partners. Let's stick to the fundamentals of what we need to do and the kind of ideation you need to be constantly doing if you want to solve the big important problems of the world. So absolutely, I always say this is the best time in the history of the world to be doing what we're doing. I'm appalled when I read articles about, you know, the end of innovation and there are no opportunities. It is just so crazy to me, right? When every field is wide open. I mean, you could have talked here for 12 hours with Bill about the future of AI and never gotten to the end of it. But the same thing is happening in medicine with the regenerative medicine and a whole bunch of things we can talk about. Or energy. No matter what our politicians say, we don't have the energy technologies we need at the cost we need them. And you can just go down the line. What's happening with education, with the advent of MOOCs and blended learning? There has never, ever been in my career a period like this with more huge opportunities. But you got to have the right skills to be able to identify those opportunities and to make them come to life.
Since you are an organization that watches education carefully, even benchmarks it, what is your sense of MOOCs? What do they mean for education?
Well, MOOCs, I say we're in the MOOC 0.1 era of MOOCs. They're still basically, you know, repeating what goes on in the classroom, but I was working over the weekend, last weekend, with a friend, and we were Skyping a fellow in Kathmandu at 15,000 feet, and we were telling him about MOOCs, and he's in this little village, and he's getting all excited because he said, my gosh, you know, I've been struggling so hard to get my education. Now I'm going to have access to the best teachers in the world at 15,000 feet. He started out as a Sherpa, but he's a really smart guy, right? And for him, it's like, boom, the world is now flat, right? Now I can do anything. But it's not just that, it's what's going on in blended learning. You know, you asked about McCarthy and Doug Engelbart.
Blended learning, explain.
Blended learning means where you augment the teacher, you don't replace them. So MOOCs have you know, my little joke about MOOCs is, how many political sciences teachers does the world need? 3? Maybe 5, I don't know. But that's not what's going to change education in America. We're going to change America by giving teachers for the first time, tools that augment their teaching ability. And we have a program teaching algebra because that's the nexus of, I dare say, everybody in this room got through algebra, and if they didn't, they wouldn't be here, right? If you don't get through algebra, you can't be an auto mechanic today because you can't read a graph. You're stuck. And if you go to the top metropolitan cities in America, the disadvantaged kids, less than 50% of them get through. And if you go to Detroit, it's less than 25%. Imagine that. What I always say when I mention that is, if an enemy did that to us, we'd go to war with them. And we're doing it to ourselves. So getting kids so they can participate in this world, what I call this world of abundance in the global innovation economy, they can only participate in it if we can get them educated. Otherwise, they're going to be angry, they're going to feel like they're in a world of scarcity, and we can't have a great country. But for the first time in all the years we worked on education, we can actually see tools now that we've actually used with thousands of kids across Texas and Florida with our great partners there. And we have a trial going in London right now with kids from Bangladesh and the Middle East and others. And basically, we're getting the same results in both cases. If you test how they're doing today, about 50% of the kids learn new algebra, and about 10% learn a lot. They have one of those great teachers. And we could basically reverse that. 50% of the kids are up where the great teachers are, and everybody gets through some algebra.
And that's based on blended? What you'd call blended?
Blended learning. And the reason it works is if you design it correctly, you can teach the way we learn the best. So you can teach, well, if you want to learn, you want to do it, you have to do it. You want to have immediate feedback, recursive. You want to have multiple representations because we all learn in different ways. You want to do it in teams. You want to have a mentor. A mentor is incredibly powerful. and you want to have the right incentives. If you can instantiate those principles, we learn really fast and kids learn really fast. And we found a way to do that. We teach with stories, equations, numerics, graphs, and little motion examples. And it's all been built together. And we teach the fundamentals of algebra using this technology. So we don't replace the whole curriculum, we only replace a little piece. But it's enough to have this profound impact on learning.
And has it been deployed at the state level, or are you getting traction in terms of getting it out into classrooms on a
So
on a national
we're working
scale?
our way through this. The first thing we had to do is prove that it works. And we had to prove that it worked with every demographic group. So we've done that with rich kids, poor kids, every nationality you can think of, non-English speaking kids. It's not the smart kids that you worry about, right? They find a way. You have to prove that it works with the most disadvantaged kids. And that's what we've been able to do over the last couple of years. And now we're working to take it the next step.
So recently, MIT-X, this consortium of Harvard and MIT and others, rolled out this automated assessment tool, which was greeted with a great deal of controversy. It's open source, and they assert that in certain conditions, it does as well as human graders. Maybe this is actually a question for Bill, too, in terms of the state of that technology or the potential. I mean, one, can it be as good as a human grader? And two, if it can, is it obvious that we should deploy it on a large scale?
Well, let me take a little piece of that Bill can add to it. So it depends on what you're trying to do, right? But I do think the future of MOOCs and blended learning is automated assessment, so you know in real time how the student's doing. You will have a computer tutor is part of it as well. Obviously, you're going to have rich multimedia collateral information is part of it. So MOOCs over time are going to become a platform that's more like what I described, what we can do with blended learning. We're going to be able to add, from a computer point of view, bit by bit over time, those capabilities to MOOCs. And once we do that, we're past the version 1.0 MOOC technology.
I'm very optimistic about the future of automatic assessment. I don't have any way to judge this particular one, but I think there's technology that's becoming available that's going to make that a reality.
So let's move a little bit beyond computing. I wanted to delve a little bit into some of the other areas, and I was just wondering if there are, so Siri's gotten so much attention. Is there anything in the medicine and energy areas, for example, or biotech, that has that potential, or would you call out sort of work that you've done that is on that level? What about energy first, actually?
Well, we work on a number of energy technologies. They tend to be, they're long and hard term. So we have low-cost silicon. We have a bunch of things that we're doing. Here's one the audience might appreciate in the medicine space. If any of you have diabetes or some other ailment where you have to take pills or injections often, the problem is that you take the drug, it goes up to a peak. It probably goes above the level you want, so if it goes up too high, you have a side effect from it. And then it falls down, and then now it has no therapeutic value. So there are drugs where you have to take them every 2 hours. Well, nobody does that. So we've actually invented a platform technology that'll attach itself to a drug. So instead of the drug doing this every time you take it, it actually goes like this. So instead of having to take the drug every 2 hours, you can take it once a week.
What's the mechanism for delivery?
I'm not at liberty to say that, but it's...
Can you say if it's not injected?
It's really clever.
and FDA approval, are you at that stage of applying for it?
We're still working on it. But here's the other advantage of it. There are a lot of drugs you can't take today because the side effects are so bad. And so by developing this platform, we think we're going to open up hundreds of drugs that haven't been used before for cancer and diabetes and other kinds of diseases that can make that kind of an impact. So it's a big deal.
I saw that both of you actually were at a workshop earlier this week at, or maybe it was last week at SRI on robotics and the workforce. And you know, Bill was pretty optimistic about the transition. How are you feeling about the deployment of automation technologies and the impact they'll have on the workforce? Are we going to get through this transition without huge economic consequences, negative ones?
Well, so the big issue is, you know, are robots going to create more jobs or eliminate more jobs, right? That's the big, one of the big hot issues. This has always come up. We've always created more jobs, but you never can prove that when you're in the middle of it. So, you know, 20 years ago, I was having this debate about knowledge technologies, and I'd say to my friends, well, you know, we've always done it before. Here's one way to think about it. So probably all of you have heard about the long tail. You know, so the idea is, here's the number of customers you have in a given company, and over here, you have the number of companies. So there's a, let's say in today's world, how many customers does Facebook have? 1 billion? Let's say they have 1 billion, okay? So they're the biggest company in the world in terms of customers. And down over here, you've got a company that has 1 customer. They'll make additive chocolate sculptures of your friends for you, one at a time. I wouldn't say that would meet the normal SRI criteria, but nevertheless, you get the idea. So there's a distribution of companies. So imagine what's going to happen, though. Some companies are going to be up around 5 billion. And the number of companies that make smaller numbers of, that serve smaller number of customers is going to go way out there, too. And so there's going to be a line between those. Now, I'm sure we could name lots of the ones that are going to be the really big ones, and we can have a lot of fun and name a lot of the small ones. But I dare say, I have no idea how many there are in the middle. That's where the jobs are. And I don't think we can imagine what they are. So I don't know your answer. All I know is I think there's going to be thousands of opportunities in there that we can't even imagine.
Yeah, I think that's a real answer. So, you know, over the years, from time to time, SRI has been involved in some really edgy technology research. I mean, even parapsychology over the history. And actually, some of the edgiest stuff is some of the most, you know, most interesting. I don't know if you'd call it edgy or just interesting. You're managing now, for example, the Hat Creek SETI Observatory. And
what are we
you found any aliens recently?
No. No.
Not in space.
Interesting.
We didn't take it over for that purpose, but somebody in the room may be interested. I don't know. What we use it for is we're working on the next generation of satellites. They're called CubeSats. They're little satellites. They're about this big, and you can put them up with a $100,000 satellite. Or you can put a bunch of them onto a bigger satellite, and they kind of squirt out into the air. The problem is when they squirt out into the air, you know, let's say 10 of these at once, you can't really sort them out fast enough. And so we're using that particular radar array to be able to track small satellites as they go around the Earth. And these small satellites will be used for all kinds of things, for navigation and communication and lots of things, surveillance, agriculture, that sort of thing.
Do you guys have activities in drones? Do you design drones, or?
We certainly do computer vision sorts of things with drones and other things, and but to my knowledge, we aren't building drones, are we? No. Okay.
And you're also you're also still managing Arecibo, is that right?
Yes, we run Arecibo. We run the world's biggest observatory, and as part of the basic research we do a lot of atmospheric research. We do you know, upper atmosphere research for lots of reasons. We invented in one of the most revolutionary advances in radar science to be able to see what's going on in the upper atmosphere. and for global warming and a whole bunch of reasons. We don't know very much what's going up there. And most radars, you see them, they're these big things that move very slowly. You've seen the kind of dishes. Well, like the dish up on the Stanford Hill, they look like that. This one doesn't look like that. It's just this flat array about as big as half of a football field, and it's got 10,000 small radars in it in an array. And what you do is you change the phase of those 10,000 individual radars. And so depending on how the wave front comes out, you can actually sweep the signal through the upper atmosphere. So it's the first time ever we've actually been able to take a dynamic picture, like a video picture of what's happening in the upper atmosphere. It's pretty cool.
For climate modeling or?
Climate modeling, navigation, solar flux, the kind of radiation that's coming down from, we've got ones up in toward the North Pole primarily right now.
So given both of your expertise, yours in displays, one of the hot topics in Silicon Valley is Google Glass right now. And one of the most interesting criticisms that critiques of it, I know it's way too early to say anything about it, but bear with me here. The people who use it love it, and people who have to talk to people who are wearing Google Glass hate it, which I think is an interesting, I've only put one on once, I have no deep experience here, but just both in terms of your notion of augmented reality and your notion of display, I was just wondering if you expect these things to be ubiquitous, that will be instrumented as a...
Oh, yes, I do. I don't know whether they will look like Google Glass, okay? And I don't know whether they're going to be obtrusive enough to have that problem of, am I talking to this person or am I not talking to this person? Right. But I'm very confident that we're going to walk around with lots of computational devices that will help us see things, hear things, and connect.
Yeah. I have a pair on tonight. John, I hope it didn't bother you too much.
That's the next generation. They work really well.
They're terrific.
But in terms of, well, let me ask you, I've heard that there are limiting factors to even the best augmented reality in terms of sort of the biological aspect of it. There's something like 15% of the people who put on augmented reality no matter how perfect they are, they get sick anyway.
Well, you do. There's people have different reactions to them, and we still basically can only pay attention to one thing at a time, which is why it's kind of annoying when somebody has got a display right there and they're paying attention to it, and you're hoping they'll pay attention to you. Yeah. But for a lot of things, if you're sitting there in the audience, perfect. Yeah.
Well, I want to turn to these, but actually before I do, one of the things I learned in doing my background research, that there's a Carlson's Law. Yeah. And as it's been stated, it says, in a world where so many people now have access to education and cheap tools of innovation, innovation that happens from the bottom up tends to be chaotic but smart. Innovation that happens from the top down tends to be orderly but dumb. When did you...
I did not coin this.
This is an interpretation of something?
No. This, John has a colleague named Tom Friedman. And this is what you get if you hang around with reporters. So all of a sudden, some of you will recognize this syndrome. It's a very dangerous thing. I was talking with Tom, and he loved this idea. It actually means the top-down part adapts slowly. It doesn't quite sound that way, but that's what was meant by it. And Tom, in his latest book, actually wrote up a whole big section about this. So, so you can all complain to Tom.
Okay, that sounds good. So I want to turn to the questions. It's fitting. The first one comes from Vint Cerf.
Dangerous.
What things facilitate innovative thinking? What interferes with innovative thinking?
Well, so I'd start off with important problems, number one. If you don't do that, there's no hope. You need to have an open environment where people are constantly sharing ideas and iterating, we call it their value proposition. Before you start spending a lot of money on technology, you have to be able to make the story. So you need a You need colleagues who are willing to iterate with you continuously. Obviously, too much bureaucracy stops it cold. It won't work. So it's pretty, I think, pretty obvious things to this audience. Things get in the way of your ability to share ideas. I'll tell you a funny story. One of our folks worked for the Israeli intelligence service. And when he got put into it, he had no experience and no resources, and they gave them these existential problems to solve, and if they didn't, hundreds or thousands of people might die. And he had no experience and no resources. All they could do was basically brainstorm with each other. But they had one advantage. They could go to talk to anybody they wanted to, even a 4-star general, if he had a piece of information they needed. This fellow came to Stanford, got his MBA, went to work for a company. He discovered in that company that if he needed the piece of information, he had to go up the management chain, then go over, and then go down the management chain. He put up with that for a couple months, and he said, I can't be here. This is ridiculous. If you can't get the information you need fast enough in today's world, you're not going to survive. That's a perfect example of you can't let those kind of things get in the way in a world that moves as fast in the global innovation economy, where technology is all exponential, where the competition is growing near exponentially. You can't put up with that.
I'll just add one thing that fosters innovation. Really understanding what other people are doing, understanding it in the sense of being an alternative to the way you're doing it. And it is amazing how few people catch on to that.
It's true.
So it's sort of the opposite of NIH, would you say?
Yeah, well, so it's so easy to think of your solution as the way to address that problem. And of course, 2 or 3 other colleagues who are doing something like that, only not quite as good. But you don't pay any attention to people who are doing things that also solve that problem in a different way.
By the way, NIH is another one. NIH is a ubiquitous problem for most companies, and it's a killer, right? Arrogance is a killer. Arrogance kills, absolute arrogance kills absolutely. Really, the world's too competitive. You can't afford to be arrogant anymore. If you're not humble, Bill didn't tell his story about Siri and what he did. He not the kind of guy he is, right? But it was quite an achievement,
So this is a perennial, but it's a good question. I think from John Navis or Navis. Are we graduating and keeping enough scientists and engineers to maintain our edge in innovation? And if not, what can be done to improve the situation? Is there a technology answer, at least in part?
Well, there's only one scarce resource in the world today, and that is really smart, passionate, motivated people. That is it. There aren't enough of those people. The US economy rides on the back of a tiny percentage of people, a lot of them in this room, who go out and do miraculous things that create jobs for other people. The fact that we limit those really smart people from coming into the United States is a really benighted, feckless thing to do. I can't imagine. So the answer is no, we do not have enough of those. I don't have a strong view on that, by the way.
This is a question for Curt. How do you see your physics background help with what you are doing? Any advice for physics students in college? If you had a chance to choose again, would you choose physics again?
Well, everybody should study physics, right?
Go into computer science.
I actually think it's very helpful for me in 2 ways. One of which is because it's kind of a broad fundamental background, and because SRI does so many different things, that really helps. But the other thing they drive home in physics is to come up with simple fundamental solutions. As simple as possible, but no simpler. And so it does give you a perspective on the world of trying to always figure out, how do we come to the essence of this? By the way, this is one of the things we teach everybody at SRI. It's one of the innovation fundamentals is, what's the key insight into that problem that would make it really work? I gave you one tonight about education, those 6 things that I mentioned. That's the key insight into solving our problem. If you don't have that key insight to that, you'll create like 99% of the educational software out there, you'll create a game. It may be fun, but it doesn't educate. You've got to really have that perspective. And I think physicists have that drilled into them. It's just part of the discipline.
Do you find that for a spin out to be successful, you must spin out the key participants with it?
No.
Interesting.
So what we find is, as I told you, these ideas are decades in the making. We find these disruptive opportunities. We bring in an entrepreneur. We often, especially nowadays, we bring in not just the CEO to be, but also the VP of engineering or CTO to be, and they often have a technical team. Okay. So our people, most of them, aren't the right people to go in the spin-off. Some of them are, and some of them go, and that's fine. But I don't think it's essential at all to have the people who created that technology decades ago go.
Do you have people round trip? Do people go out and come back?
We do, indeed. Some of them have done several round trips. And we're always happy to see them back.
We're always, you see, if we were a big company, the team would all have to leave to take the technology with them. But because we actively incubate it, the technology transfer part is taken care of. Because we're all one family working on this to make sense out of it.
Okay. Here's one hard and one maybe easy. What are the top 3 innovations / impact the world from SRI? Well, let's just ask that.
The top 3.
The top 3 innovations from SRI.
Well, I mean, what do you say about the computer mouse, Windows, hypertext, and a bunch of other things? That's got to be up there, right? Yeah. Intuitive Surgical is a $27 billion company that started the whole revolution in minimal invasive. I think Phil Green, who did that work, is here tonight. That's a pretty big one. I would say going forward, the work we're doing in digital education may top everything, because if we don't educate our kids, nothing else matters. It doesn't matter what the government does, it doesn't matter what we do. If half the population can't participate, America's got a huge problem. So there's 3.
Yeah. What is the ratio of PhDs to your 2,500 employees?
I don't know SRI-wide. My group's about 50%.
Here's another top 3 question. What are the top 3 important problems to solve?
Oh.
I don't know why 3.
I've already mentioned education twice, Bill. Do you want to throw one out?
I think you mentioned this issue of putting technology into the world in a way that people can adapt to it. I think that's a really important problem, and I think that's what successful technologies do.
So I'll mention another one that might surprise you. I actually think it's the way we innovate. We're doing a terrible job at innovation. If you take any measure of innovative performance in the national labs or other labs around the world, people are very frustrated that their ability to actually get things done and make the impact that they want to and they're capable of doing. And we've become convinced, having thousands of people come to SRI, is that they haven't figured out a way, it's Vince's question again, of getting the barriers out of the way. Google has a process that's very effective, but most places don't. And I think if we could transform that, we're working with the Air Force Research Labs right now and others. I think we could, well, let me put it this way. When we went through the Deming era, when we went from low product quality to high product quality and low cost, that difference was thousands to 1. It wasn't a little thing. It was like, oh my goodness, this really is a completely different world. When I'm being very, very conservative, I say we can improve our output by 100%. I actually think it's more like 500 to 1,000% for innovation as well, if we all kind of got together about what really works.
Is there a region of the world that's doing a better job than the United States? Is there a region of the world that's doing a better job than the US?
Probably not. I mean, Silicon Valley is a singularity in every way. There's no place like this, right, with so many brilliant people who really have spent their lives understanding how to do this. But there are always great people everywhere you go who do know what to do, right?
This is a democracy question. Any plan to work on a version 2.0 voting system, transparent, open source, with strong encryption?
We do look at voting systems. It turns out to be a really hard problem. I'm not optimistic about a solution to that soon.
Yeah. Okay. No, go ahead. No. Effects of patent policy on innovation. What is the effect of patent policy on innovation? Our patent policy, I guess, the current patent policy.
Well, I mean, there are two parts to that, I guess. One is the recent changes, first the file. I think that favors big companies a little more than I would like, but I don't think it's the end of the world. The second is, what's going on with patent litigation right now, which has gotten to be a much bigger issue. I'm not sure what we do about that. It's just a fact of life, and we all have to put up with. Okay. I don't know how to fix that.
Okay. I think this is a good question to end on, and they're asking, can you describe your innovation process in a few words?
Yes. So the first thing is you need to have a common vocabulary to describe the process of innovation. Go home and try this experiment with your teams. Have them write down the definition of innovation, customer value, and a value proposition on Post-it notes and stick them on the wall. If they don't have reasonable agreement, then your organization is going slower than it should. That's number one. Do you have a process where people come together and do ideation in a serious way on a regular basis? Not brainstorming meetings, ones that are really driven on a regular basis with the right people in the room. In our ventures group, we have our venture friends who come every 6 weeks and spend the better part of a day with us as one of the teams on a regular basis to critique and involve some of the best people in the world to make our ideas better, avoid the NIH problem and lots of other things. One of the things we make a big deal about is a value proposition. So here's a very specific thing you can use now for the rest of your life. A value proposition, the way we define it, is what's the big important need? What's the approach to address that need? Is it unique? Is it defensible? What are the benefits per cost of that particular approach to address that need? That's the value of the idea. And why is that better than the competition or the alternatives? So we simply call it NABC. An important need with a unique, compelling approach with superior benefits per cost when compared to the competition or the alternatives. Just having that simple framework so that every presentation addresses those 4 questions makes a huge difference. Most presentations that you see in universities in particular, we make a joke about them. We call them big A's. They're all about the approach. So, a typical presentation in most places says what the world needs is a 5 gigabit per second communication system. Our approach is we're going to build the 5 gigabit per second communication system. The benefits per cost are you will have a 5 gigabit per second. And there's no competition because ours goes at 5 and the other one goes at 4.999999. So you can see that ours is a lot better. So, it sounds like a joke, and it kind of is a joke, but those of you who listen to lots of technical presentations will recognize the truth of that. So having a language and metrics and standard processes makes a huge difference.
Thank you both. You're right. I could have spent 2 hours talking to Bill just about AI, probably. And I'm stunned by the book.